going to do some problems here with my calculator. And I'm doing calculus, so before I do anything, I always check to see what mode I'm in, because in physics, I'm often in degree mode, and in calculus, I need to be in radian mode. So I just go ahead and check that right off the bat. I know many of you have both of those things to do with your calculators too. All right, so what do Chapter 6 problems look like when they're calculator active? Probably going to see a little bit of that on our Chapter 6 test, so I want to go over that. So let's take a look at these. Number one, if f prime of x is this, so this is some derivative, and f of 3 equals 7, then f of 2 equals I don't know what. Okay, so thought process. Well, I've got derivative, and I want to get back to function. So we should be thinking fundamental theorem of calculus to get back there. I know in general, one way of writing the fundo theorem of calculus is that, right? The integral from a to b of f prime of x, the integral of f prime, that gets you back to here, and we have to do that subtraction. So let's just let's write this out. I think writing fundamental theorem of calculus expressions is really good practice, something you should be very comfortable doing. So here, how do I know where to go from where to where? Well, 2 and 3 are the two things. This is the thing I don't know about that I'm looking for, and 3 is the thing that I do know about. So I'm going to go from 2 to 3. And then f prime of x is cosine of x squared dx. So that would be equal to f of 3, which is 7. I think I'm going to write that first before I write the 7 down, but that is equal to 7. And the f of 2, this is the thing I'm looking for. This is 7, and this I'm going to get with my calculator. Now, why do I need my calculator? Can I just do this? Can I just find the antiderivative of cosine of x squared? No, you can't. Not because you're not smart enough, or not because your calculus teacher didn't do a good job teaching you how to take antiderivatives. Not for any reason like that. It's not your fault, not mine. You just can't do it. It's taking derivatives is easy. Taking antiderivatives, things have to be like just so to be able to do it. Kind of analogous to factoring trinomials. Like if you think back to your algebra experience, when your algebra teacher can't just go like making up problems like this. Oh, I'll just pick some numbers and like, okay, go factor that. Nope, sorry, that's not going to work, because those numbers have to be just so for it to be factorable. And then, of course, if it doesn't factor, you got to use the quadratic formula, whatever. Or use your calculator and graph it and see where it crosses. So anyway, this can't be done in any other way. So what I need here, my f of 2 that I'm looking for is equal to, just doing some algebra here, it's 7 minus this expression, which I'm going to pop out of my calculator here in a second. So that's what I'm looking for, 7 minus that. So let's do that right on the home screen. So I'm going to go to Math 9, and oops, you know what I'm going to do? I'm going to do the whole thing. 7 minus Math 9. I don't need to do just two separate things, right? Make that whole expression right there. From 2 to 3 of cosine of x squared and like I need another, there we go, dx, and that looks good, and that gets me that. Alrighty, so how how about this one? Graph of the function f, which has a domain of 0 to 7, is shown in the figure above. The graph consists of a quarter circle of radius 3. Okay, so let's see. What's the area of a circle is pi r squared. So that's a quarter circle. So that's 9 pi over 4. I'm just going to put that area in right there. I'm just feeling that we're going to need that. And a segment with slope of -1. Okay. Let b be a positive number such that the area from 0 to b, or f of x, is 0. Okay. What's the value of b? So that means, so there's some number b. It's going to be definitely in between 3 and 7, right? All those are between 3 and 7. That's not helpful. So that the area cancels out. I mean, that's how I'm interpreting that. So the area from 0 to wherever is equal to 0. So that means I need the area of this triangle. There's different ways you could do this. You could actually find the equation for this and set it up like with a fancy integral. But I know however far I'm going over here, because the slope of this is -1, I'm just getting a triangle that is, I'm going to say, this distance. What should I call that distance? I don't want to use b because b is the distance all the way across, and I don't want to get confused about that. So I got a sneaking suspicion it's this. I'll tell you why I think that in just a second. So I need to find, let's call this side of this triangle here, not b, but, let's call it a. How about that? So 1/2 base times height. Because the slope is -1, if this is a, this is also a. And that means the area of this triangle is 1/2 a squared. So I just need that number a, 1/2 a squared, to be equal to the area of the this, because this is positive area and this is negative area, and I'm trying to get them to cancel out, right? So a squared is going to be equal to 9 pi, that's a 2, 9 pi over 2. So a is equal to the square root of 9 pi over 2, which is 3.760. Now, cool your jets. Take a deep breath. That's not the answer. That's this side of the triangle. And they want to know like the area from 0 to wherever, so it's 3 plus that. So that's why I just saw that 3 thing there, and I was thinking, oh, I bet they put both answers there. So these are the two answers that are 3 apart from each other, so that's why I sniffed that out. All right, so that's that. This number 3 is very, very like number 1. It's basically the same thing. Only difference is in the way that they're presenting. Here they said f prime is this, and we're looking for f. And then here they're saying that h is an antiderivative of this. So same thing, right? Because, of course, f is an antiderivative of f prime by definition. So here's my fundo theorem expression. The integral from somewhere to somewhere of this is equal to, if I knew the here, if h is an antiderivative of this, well, that's what I need over here for the fundamental theorem. I need an antiderivative. So it looks like 5 and 2 are the things. One of them I know, and one of them is the one I'm looking for. So h of 5 minus h2, which means that needs to go from 2 to 5, right? 2 to 5 means 5 minus 2, to make sure that get that order right. So just like the last one, that means that this, the thing that I'm looking for, adding that over here, is equal to pi minus this integral expression right here. All right, so let's do it. Pi minus math 9 going from 2 to 5. Got, let's see, how do I get that fraction thing? Let's do it like this so I don't mess it up. X cubed plus the sine of x over x squared plus 2. And that should do it. Hope that's an answer. It is. Okay. Particle travels. So this is a context. These one-dimensional motion problems, definitely something, got some more practice of that with a free response too. That's definitely something where we could expect to have some calculator work. Particle travels along the straight line. Often, a lot of the time, we're given the velocity because that's kind of like f prime, right? If you got your position and then you get your velocity. Sometimes it's called x or s, whatever. Our book likes to use s. College Board, I think, is probably more uses x, and then acceleration. So this is that f prime, and you can get back to this by taking the antiderivative or integral, and then this is your derivative. So lots of good stuff to do there. Here is the velocity function, meters per second. What's the total distance traveled? So total distance is equal to the integral, the absolute value of velocity, dt, from 0 to 2. So, I mean, if you know that, and you should, the total distance is the absolute value, the integral of speed, then, boy, that's pretty easy, isn't it? So, let's go math 9. Going to go from 0 to 2. And in here I've got 3 e to the negative x over 2 times, you could hit the times thing just to make yourself feel better about what's happening there, but your calculator understands that two things next to each other means multiply. I think I've got open, and then I think I need one more closed parentheses there. It's nice all this math print that our calculator does, but you do have to be very careful with the parentheses. And it does do the different sizes of them, so you can kind of see what's matching up. That bigger one, you see how these are slightly different size, those are smaller, so that helps, I think, and matched up. So it looks like we're 1.850. Oh no, I bet you that's wrong. I bet you that's wrong because I forgot the absolute value signs. So that is the displacement, right? If you don't put the absolute value signs, then the integral of velocity is displacement. So let's see if I can. Oh, I don't know if I can. There might be a way. Oops, that's not it. There might be a way to insert. Let's see. Insert math. Yeah, and then there's. I bet you there's a copy and paste kind of thing too. Oh, there's absolute value there too. No, that was there. So, what happened there? Go away. So let's just delete all this. Okay, so in here, I just need to do this again. Sorry about that. So 3, I guess it's good for me to make mistakes like that so we can talk about them. minus x over 2, or I can just pretend that I did that on purpose. All right, now we should be good. Thinking. So it's this. And of course they did have that displacement, if you forget those absolute value signs. Of course they're going to have that there. Okay, so this is similar stuff here in number 5, but in the context of a free response question. So here it's definitely important to understand it's not just a matter of writing down whatever the correct answers are. We need to show work and communicate our calculus process so that whoever's reading this can understand what we're doing. So let's see, for time greater than or equal to 0, particle moves along the x-axis. The velocity is given by this, and the particle is at position x equals 2 at time 4. So that right away is telling me probably at some point in the problem they're going to ask me where it is at some time, and I'm going to have to do like this kind of fundamental theorem, because position is the antiderivative of velocity. So in this context, the fundamental theorem expression, it looks like this, right? Just like sort of most generic one looks like this. If you're talking about motion, then velocity antiderivatizes to position. I don't think that's a word. I'm sure it's not. So that's probably coming. At time 4, is the particle speeding up or slowing down? Well, that depends on the signs of position and velocity. So let's see. The velocity at time 4, and I'm going to show you a trick that often, not always, but it often saves a lot of time in these. I'm going to go ahead and put the velocity function as y1. 1 plus 2 sine squared over 2. I'm anticipating that I'm probably going to have to type that several times, so if I do that, I don't have to type it any more times. I can just refer to it as, I can pull it up from the variables menu in my y variables, y1, right, because it's in y1. All right, so that's there now. So at time 4, is the particle speeding up or slowing down? So the first thing I just need to do, I just need to know what the value is when you plug that in. So there's a couple ways you can do that. You can, let me go to my window real quick. If I wanted to graph this, I'm interested in, this is at time 4, 0 to 3. So I think I'd probably be interested in looking at 0 to 4. And then y values, I have no idea what kind of y values this thing takes on. I could start with the negative 10 to 10 and just see how it looks. Not terrible. Could have been smaller values, but that works. Okay, so there's a couple things that I can do here to find the velocity and the acceleration. This is a graph of velocity. So I can just go to second calculate value and type in 4. Oh, did I not type value? I guess I typed something else. That doesn't look right. It should be just asking me for, so value, I think I accidentally hit 2 there. So at x equals 4, this is equal to 2.979. You don't actually need to know the value there. You could just say that 4 is greater than 0. That's fine. That's all we really need to know here, whether the signs agree or not. And then the acceleration, you could look at it and say, oh, the acceleration at 4 is, actually, it's kind of hard to tell. But if it's like obviously going up, you can't say that it's positive because I looked at the calculator. So I'm going to actually just find the value. Second, calculate. How do I do that? Well, acceleration is the slope dy dx of this at x equals 4. So the slope, oh, it actually has turned back down. So it's negative 1.164. So there's my signs of those. Is it speeding up or slowing down? It is slowing. Justify, because the velocity is positive and the acceleration is negative. All right. On what subintervals of that, if any, is the graph of... That's number 6. B. For all times in this from 0 to 3, when the particle changes direction, find all times when it changes direction and justify your answer. It changes direction when velocity goes from positive to negative or vice versa. Right? So this is a graph of velocity. So let's find the zeros. This one looks like it's in between 2 and 3. So our College Board wants 3 decimal places, correct rounding. And there, just to note, that's going from positive to negative. Kind of a note for myself there. And then the velocity at, looks like we got another one here, another 0 between 3 and 4. 3.394. And there it's going negative to positive. So I'm going to say the particle changes, particle, that's not how you spell that, particle, changes direction at times 2.707 and 3.394 because the velocity changes sign. It's not because the velocity is equal to 0. The important thing is the velocity changes sign. That's what causes the direction change. Of course, if you're looking for where does the velocity change sign, you should look at where it's 0. But the real reason is the sign change of the velocity, because v of t changes sign. Okay? Oh, could you see that down there? Yeah. Find the position of the particle at time equals 0. So that's what we were suspecting there was going to be something like that. So let's see. The integral of velocity with respect to time is equal to position minus position. That is a fundamental theorem of calculus right there. Now I want to know about time 0, and I know about time 4. 0 to 4. So that's what I need to do. This I'm going to find with my calculator. And I can do it right on this screen if I want to. You can just go to second calculate and number 7. There's your integral. So lower limit, we want to go from 0 to 4. And you get to watch it shaded in, which is kind of exciting. So that's equal to 5.815. And then the position at time 4 is 2. And that is the thing that I'm looking for. So looks like I need to find the position at time 0 is going to be 2 minus that. So is that negative 3.815, right? 2 minus... I'm slightly embarrassed that I just did that with a calculator because it's obviously that, but you know, I make some kind of silly mistake. Okay, and then find the total distance the particle travels from 0 to 3. I think I can squeeze that in here. So total distance is just the integral 0 to 3 absolute value u t dt. You should write this down. I know that you can just type this right into your calculator and drop the answer. Bad idea. You need to write this down. So got that written down. Now I'm just going to enter it into my calculator. What math 9 0 to 3. I'm not going to type this function back in because it's in my y equals, so I can just pull it up from the y variables menu. Right, y1, there it is. And oh, I forgot the absolute value signs again. There we go. I think I got the details right. 0 to 3, 5.301. There's not a lot you have to write, but you do need to write this. This is clear communication. This is how you do it. That's the answer. Okay, so number 6. You know what? Let's use, I'll recycle this other page of this. That should work. Okay, so here's a function. I don't know what the g function is, but the derivative of it is this. And the second derivative, thank you very much, College Board, for doing this for us, is that. We could have done this. They could have asked us. And g of 1 is 2. I know what a derivative function is, and I've got a value of the original function. That reeks of fundamental theorem again. Find all values of x in the interval from 0.12 to 1 at which the graph of g has a horizontal tangent line. You know, I'm going to do the same thing that I did in the last one. I'm going to go ahead and graph this derivative, and I bet that's going to be useful. So I got sine of x plus 1 over x. Okay. So all values of x in this interval where the graph of g has a horizontal tangent line. So g has horizontal tangent line when the slope is 0, when g prime is equal to 0. And so let's go ahead and graph. It looks like we're just interested in this interval right here. There's nothing outside of that. So I'm going to graph it on that interval from 0.12 to 1. And I don't know about the y values. Probably they don't get that big and small, but we can just see. Yeah, okay, I don't like that. So I'm going to go from, let's have about -2 to 2. I want to see a little bit better what's going on. Oh, yeah. Okay, nice, nice, nice. So where g has a horizontal tangent line, so that's when g prime is equal to 0. This is a graph of g prime, so where is it equal to 0? Let's find the zeros. Not looking for value, sorry, looking for zeros. One of them is, let's see, that's 0.12. I don't know where that is. So I guess I'm going to play the little cursor game. Find this one first. Pick a point on the left and the right. So that's at x equals 0.163, rounded to 3 decimal places. And the other one is at 0.359. You're wondering, what's up with that? I thought we were finding zeros. Do you know what 1 times 10 to the negative 13th is? 0. Why isn't the calculator saying 0? Because it's a stupid machine and it's doing like approximating stuff and it's just gets a shade off and it doesn't know what to do, so it just says something dumb like that. Okay. B, on what subintervals, if any, is the graph of G concave down? So G is concave down when G double prime is negative, and that's the same. G double prime is negative. You know what? It's not or. It's like this is the same thing. When G double prime is negative, which means if G double prime is negative, that means that's where G prime is decreasing. It's where the slope of G prime is negative, because the slope of G prime is the same as this. When G prime is decreasing. Now you could find that they gave us this, so you could graph that and figure out when that's negative, whatever. But I think I have everything that I need here. So I just need to figure out where this is decreasing. And let's see. So I think I want to know what that minimum is right there. So second, calculate minimum, and that's between, I don't know where it is, it's in between that and that. So the first subinterval is from 0.12 to wherever this minimum is, 0.223. And then where else is it decreasing? It looks like it's increasing the rest of the way here, but you would have to be, I would be a little bit nervous about this, because this is, the resolution on these screens is not great. It's possible that it's started to come down here and we just can't tell. So I'm just going to double check here by looking for, is there a maximum? If I go from here all the way to this edge of the screen is 1. And the maximum's at 1. So that means it increased all the way there because it's at that endpoint. Cool. So that is the subinterval we're looking for, only that one. That is where this was decreasing, which means that's where the second derivative would be negative. And you could certainly have just graphed this and used that. Not a problem. Write an equation for the line tangent to the graph of G at x equals 0.3. Okay, so to be able to do that, I need to know what G of 0.3 is, and I also need to know what G prime of 0.3 is. I need those two things. That would give me my point, and this will give me my slope. Now to find G of 0.3, I don't have the G function, but I have the derivative, and I have another point, so this is my fundamental theorem little bit here. And I think this is, I don't know, this is maybe a slightly challenging way of them presenting this, because we're just writing the equation for a tangent line. That doesn't immediately put you in mind of fundamental theorem, but that's the only way we can access this. So if I take the integral of G prime from wherever to wherever, that gets me back to the original G function, wherever to wherever. So what do I want? I know that I want to know about 0.3, and I know about 1. So that's what we need to do. So g of 0.3 is going to be equal to, moving that over here, g of 1 is, already go 2, and minus my integral. Alright, so I can do that on this screen here, or you can go back to your home screen and do 2 minus math 9 from 0.3 to 1 of, I've got this in y1, so I can use that. Dx, that should do it. 1.546. So that is what this is. And then the slope, well, back on my graph here, this is the graph of the derivative. So I would just be looking for the value here, because this is the derivative, 0.3. And that gives me negative 0.472. So what's the equation for my tangent line? It's y minus y is equal to slope times x minus x. And last part, does the tangent line to the graph of this lie above or below? And why? Well, there's two possible things. If this is our tangent line, it's got a negative slope, so I'll sketch it like this. Either the graph of the original function, it's either up here, and this is tangent like underneath, or it's like this. And that depends entirely, 100% only, on the concavity of this. If this is concave up, the original g function, then the tangent line is going to be below it, and vice versa for concave down. So I just need to figure out what the second derivative at 0.3 is. So I've got this graph here. So this, instead of putting this into getting this into play, the second derivative is just the slope of the first derivative. So I can do second, calculate what's the slope dy dx at 0.3, and that is 8.919, which is greater than 0, or positive. So the tangent line, so that's concave up, lies below g of x. If you're thinking, like, do I need to say anything else? Do I need to make a picture? No, you just need to say, just be very clear, the second derivative is positive, so the tangent line lies below. You're good. You want to say concave up? Then you can say that in there. That's fine. All right. Free pizza.